very much, Lee. As Lee said, my name is Tim Henrion. I'm from IBM. I work in IBM's Internet of Things business unit, where we create technology and deploy solutions that deal with accessing data from the Internet of Things and building that into business and analytic systems. Now, when people think about IBM, they mostly think of Selectrics and mainframes and whatnot. But IBM is really at the forefront of the whole connecting devices, getting data from those devices, integrating that data into management systems, and providing insights from that. So I'm going to talk about a few things related to some of the things that are possible with our relationship with Aegex and their specialized hardware, which actually really fills an important niche or an important gap in a lot of chemical and petroleum, as well as public safety use cases where, we've all seen, there's sensors everywhere. You can go on the internet and, buy sensors that really do cool stuff, for a very small amount of money to generate all different types of data. One of the biggest challenges in the Internet of Things and building solutions around it is industrialized sensors and sensors for hazardous environments. And we'll talk about that a little bit and what's possible with the Aegex tablet, as well as an example in oil and gas, and some of the technologies behind these solutions, and how they're relevant to you if you're looking at either acquiring or if you're a solution provider deploying these types of solutions. So the most important thing, and something that I'm sure everybody is seeing here, is that the Internet of Things is driving from a solution consumption perspective, is that people are really getting tired of technology for technology's sake. So that, I as a technologist, when I put a neat piece of hardware in front of someone and say, you can do all kinds of cool stuff with this, they kind of say, yeah, that's great, but what does that mean to my business? Or what does it mean to my city? Or what does it mean to the job that I'm trying to get accomplished? People are really focused on buying solutions. They want a value proposition that says, here's what this solution does, and here's why that matters to you, either from a public safety or a financial perspective. And in many cases, those two things go hand in hand, especially when you're talking about scenarios that you couldn't service before because the technology didn't exist. And one of the things that we do together with Aegex is put the pieces of technology together in solutions and mine use cases where there's actual business value. There's actual value for someone to acquire this type of solution. Essentially meaning that the end result monetarily or functionally is worth more than the amount that you pay for it. So we're going to talk about a couple of different use cases here, but by no means the be-all and end-all. We're sort of going from the past, in the past being 5 years ago, where there are things that people have wanted to do, but the technology didn't exist. Hey, I have this great idea. Oh, okay, we don't have the technology to do that. Things are essentially now flipped upside down, where we have the technology to do just about anything, even stuff that people wouldn't have imagined 5 years ago. And it's now basically asking the question, which problem do you want to solve? Okay, we can put that technology together in a solution that does that. So a little background behind the partnering between IBM and Aegex and what these solutions look like is that we're essentially talking about integrating Aegex hardware, and specifically for a lot of these use cases, the Zone 1, Zone 2 compliant Windows 10 tablet into IBM cognitive solutions that deal with getting data to and from devices, being able to analyze that data, being able to provide that analyzed data into solutions that allow you to make more effective decisions. So, everybody's probably heard of Watson, playing Jeopardy, and all that type of stuff. We're taking that technology and moving it towards, okay, what other types of outcomes can we use Watson to help predict with data, both structured and unstructured data, and unstructured data basically being text and video and audio, as well as the traditional structured data my sensors are telling me that this oil pipeline pressure sensor says, this is the pressure right now, and it'll tell me that pressure, every 5 seconds or however often I want it. And that's really key to a lot of public safety use cases because in many cases, someone starts out down a journey of resolving an issue and they have data. Okay, this piece of machinery looks like it's doing this. And when a human has to interact with that, they need to be able to ask further questions. They need to be able to say, okay, I'm looking at that piece of machinery. Let me see the data sheet for that piece of machinery. Let me see the procedures for performing this particular process on that piece of machinery. And in a hazardous environment scenario, the ability to take the electronics that we've come to rely on for moving data between systems and people. Essentially, people in hazardous environments don't have access to that data, so the ability to resolve a problem quickly and at lower cost is greatly reduced. So an example of what that really means from an oil and gas perspective, where you're talking about the life cycle of problem resolution, it really all starts out with the data that can be collected from sensors, including Aegex sensors and their sensor networks, and being able to tie that data in the cloud into an asset management system like in oil and gas. Our IBM Maximo product is pretty much the industry standard, where all the valves and pumps and machinery, all the maintenance information is collected, work orders are generated, and served out to people to act upon and then update the status of. So what we're talking about, what used to be a traditionally manual process where someone comes in and enters data into the system to say, here's when the next maintenance on this equipment is due, here's the service I just performed. We're really talking about those management systems able to be driven by data. And not just able to be driven by data, but the systems are able to analyze that data and provide insight to the on-site engineer about what that actually means. Okay, my temperature sensor on this pipeline has exceeded this particular threshold for this amount of time. Is that really a problem? The systems can help make those determinations. And even in scenarios where there's not an actual failure, but there's a likelihood to be an impending failure based on the analysis of that data, the systems can actually reach out to the maintenance engineers and say, okay, it looks like something is going on in this particular area with this piece of equipment. Go out and take a look at it. Instead of, the whole idea is, instead of waiting for it to break or waiting for it to explode or waiting for it to fail, let's be able to recognize that, proactively send someone out to deal with it and deal with it at much lower cost. And then when those actual requests to the engineer in the field are actually pushed out in real time. The engineer's Aegex tablet will buzz, go look at this particular compressor on this particular natural gas line. Well, this is like the Price is Right. Our data shows that there's an anomaly in this particular area. Now, the important thing, and really where the Aegex Zone 0, Zone 1 compliance comes in, is that engineer has to go into a Zone 1 or Zone 2 environment where they traditionally have to leave this device behind and they're in front of a piece of equipment. They can't get to the data of, okay, I really need the parts list for this compressor. I really need the service instructions because I need to know if this particular coupling being at that pressure is really bad. It's normally a scenario of walking in and out of the environment to get that data and writing things down. But now in those environments, the service engineer can go directly into those environments and while analyzing the problem, can get access to all the maintenance data, all the data sheets, all the processing procedures directly on the tablet, even in that hazardous environment. They can address the problem, they can mark the work order as completed, even directly in the hazardous environment, and essentially go on to their next task. The same scenarios exist in other industries that have hazardous environments. It's almost like, a lot of my experiences with government and military intelligence, where whenever you go into a secure computing facility, you've got to leave all your stuff at the door, and you can only bring stuff in and out on paper. and you end up walking in and out of the facility a lot, where if I just had access to all the information in front of me, I could do what I was doing a lot more quickly and a lot more expediently. So, a couple of other interesting use case offerings. You can take that same scenario and expand it to condition-based monitoring of equipment as well as environment as well as people, where you can take that same data that normally comes from those particular pieces of infrastructure, and you can start to collect that over time, and you can actually apply analytics modeling technology to it, to do things like learn what a piece of machinery, what its particular sensor readings are like when it's operating normally, and be able to detect anomalies or deviations from normal, to basically be able to do predictive types of failure, predictive problem determination. That's really huge right now, being proven out in manufacturing. So, for example, in automotive manufacturers, when a robot is going to fail, it would really be nice to know before the robot fails, so that the production line doesn't stop and normal operation is not interrupted. The same thing can happen in any type of production environment where you're looking at essentially machine-driven processes, machine-driven operations, where you can now detect anomalies that you weren't able to detect previously, other than when the piece of equipment failed. And the important thing there is, by modeling normal and then looking for deviations from normal, you can now make repairs that are much more cost-effective as opposed to just waiting for the thing to break down and have to perform major repairs on it. So you can monitor infrastructure. Aegex provides the sensor hardware for those particular environments, for those particular use cases in terms of monitoring pipe pressure, monitoring pipe temperature, et cetera, connecting via a network that suits the particular environment. If it's someplace where you've got ubiquitous wireless coverage, but you may want something like LoRa for network backup in case the wireless goes out, you have the ability to make those determinations. And you're able to take that data, get it into some really advanced cognitive analysis technology in the IBM cloud. And these types of scenarios are actually cloud-to-cloud scenarios, where Aegex sensor network actually is directly connected to ours, where the data is fed. We do the analysis and provide that directly back to the network for integration and feeding directly to the engineer that's on site. You also have the ability to do environmental monitoring. Environmental monitoring is sort of, it's the normal stuff you think. What does wind look like? Are there any gas leaks being detected by gas sensors? But you also get into the areas where you're doing analysis of video, analysis of sound, to basically determine things like, instead of having to take a piece of equipment and instrument it with very specialized sensors, you actually now have the ability to stick a microphone on the side of that piece of machine and have the analytics behind that microphone learn what that machine sounds like when it's operating normally, and being able to say, well, have the analytics say, I'm hearing a little bit of a rattle, I'm hearing a bit of a tick, 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 that usually you rely on somebody with 30 years of experience who's able to go and put his or her hands on that machine and listen and say, oh, that thing probably has to be refurbished in 3 months. The sensor-driven systems now have the ability to do that same thing. So as that person that has that 30 years of experience retires, you don't have to wait 30 years to train somebody else to get to that level of expertise with the equipment. Same thing with personnel. And this really gets into public safety in terms of emergency responders, firefighters, and even other personnel in the energy industry. This right now is very big for miners, where you build a network underground in your mines and you basically put sensors on all your mine personnel, so when there's a cave-in, you know immediately who's accounted for, who's not accounted for, where they were the last time that the system saw them. And you can also use that data in terms of movement, location, and other physical aspects to determine if people are being overexerted, to determine if people are taking the most efficient paths and procedures to get their job done as effectively as possible. Even being able to do things like, there's a mine collapse, and you have somebody from one group of miners that you want to be able to send to the place where another group of miners was last seen, to be able to direct them in real time and avoid this particular tunnel because there's likely to be a collapse there. Our CEO likes to say that data is the next natural resource, because there's so much that you can actually do with it once you collect it, and the light bulb starts going off to say, well, if I have this data and that data, I can put them together and I can determine where people are when a mine collapses, and other use cases like that. The key is, in a lot of scenarios, especially in O&G hazardous scenarios as well as public service, there's been a limit to what type of data you can collect in hazardous environments, and that's one of the reasons that we're very happy to be working with Aegex on these particular use cases and providing these solutions to our customers. So a quickie, how, if you're interested in this type of technology, how you get your hands on it, how you see it demonstrated, how you see the capabilities. Aegex and IBM have the ability to do what we call rapid piloting, where essentially we work on a use case where an end user would say, I really see value in a solution if you could show me doing X. And we stand that system up in a pilot type environment in the course of a couple of weeks. We also work to mine additional use cases that get more industry specific. So for example, I personally work with some of our systems integrator partners where they tell me, okay, I have this particular public safety system. I want to integrate sensors for police gun holsters. How do I do that with your technology, and how do I analyze that data and preserve it without having to redesign my system? And we work with our hardware partners directly to get the hardware we need, get the data into the cloud, and integrate it with either existing or new applications. And most important thing is that this is really all about ecosystems. One of the things that we learned early on at IBM is we're not going to be able to provide everything end to end. We're not experts in everything. We're not experts in Zone 1, Zone 0 compliant hardware. We're not experts in particular types of sensor design to meet particular regulatory requirements. What we are experts in is, once we get the data, the ability to combine that with other types of data and also provide management systems to how that data is actually used and provided to the people in the field to allow them to gain additional insight from that data. These systems will never replace people. If you read in the newspaper some of the stuff that we've done with Watson in the cancer field, for example, we're never going to be able to diagnose a particular cancer better than a board of oncologists. But one of the things we're going to be able to do is provide those oncologists with another voice to say, okay, here's the decision you made. I've gone out and analyzed all this data from all these medical journals, and I agree with your diagnosis to a 93% probability level. And that's the same type of insight that we provide in these particular situations. We've analyzed the data that's come from the sensors and come from the machinery, and this is what we believe is happening with a 89% probability score. Or secondarily, it might be this particular type of issue, but we assign that a much lower probability score. And then a problem resolver would take that information, go into the field and look at it. And that's all I had for my 20 minutes. I don't know if we're going to take questions or move on. Or...
Yes. Do you have any questions?
All right, great.
Not